Oh, Ogdensburg. It's in northern New Jersey.
Okay. Sorry,
It's
butcher.
small town. You ain't gonna get that one right.
I should have asked. Dang it. I thought I had
Oh,
it.
you're good. No one gets it right.
All right. And then so the last 14 years he's been with his current department, Mobile, Alabama. And then he is a graduate from the Alabama Smoke Diver course, owner of Port City Fire Training. He is the president of the Alabama Firefighters Training Foundation and a contributing author for Fire Engineering, Fire Rescue, Firehouse, FDTN, and Firemanship Journal. He is an instructor at the Gulf Coast Emergency Response Academy, as well as instructor at FDIC, Firehouse Expo, Firehouse World, Water on the Fire, High Rise Operations Conference, and the Third Coast Fire Conference. He was a member of the NFPA 14 study and a co-host on the Generation Engine podcast. All right, go ahead, take it away, Captain.
All right, I'm gonna switch over and go to full screen now. All right, so I appreciate the intro. Yeah, I kind of got my hands in a lot of stuff, but it all kind of always goes back to the same thing. It's just the engine stuff. So we'll spend about 2 hours. We'll do a little bit of a break in the middle, talking about standpipes and decisions when you're first due. A lot of it really understanding the systems, what you can get out of it, and how that is going to impact your decision making. So this is my run area. My whole career has been right there. I was a firefighter on Engine 3, which is our downtown engine company, responsible for about 95% of the high rises in the city. When I got promoted, they make us get moved. I got moved, and the first opportunity I got back to come to Engine 3, I came back, and then I did the same thing when I made captain. I got moved out, and as soon as I could, I came home. So this has been home for me. I've spent my whole career pretty much right here, trying to know this run area and figure out how we could do things better for us. And a lot of that is what you're going to see in here. Was about 3 years ago was when we really revamped our operations. We rewrote all our books, got away from inch and 3/4 hose and all that kind of stuff that was department allowed, but the downtown companies were never doing, and got everyone on the same page, and how we kind of got that done and got people to accept it. So you'll see some of that, and maybe it's something you can use if you're fighting that battle as well. So before I do any class, I always start with this. Nothing in this class did I create. Is it my way, our way? It's things people taught me, and that I'm just trying to pass it on. So I always give this list. If you're looking for, stuff to read, stuff to look into, these are the guys I go to. When I have a question, these are the ones I go to. They're my friends and who I trust, and I listen to, because all their stuff's through experience. Most of the people on this list, I don't list the people from my department, just for the fact that most of them don't get out and write a bunch of stuff. So I want to give you a list of, if you're looking for something to read or to get into and study, that this is a list you can look to the same people I go to. So I started with this because this one kind of goes to not just high rise, not just standpipe operations, but any fire. And it's just some of our experiences, my personal experiences and stuff. And you'll see a few of those fires come into play in this presentation. But anytime you go, treat it as it's on fire. People say, expect fire, expect victims. And if you say it too much, it becomes cliche, but it does play out. So we'll listen to this, go through some of the radio traffic of it, and it'll kind of set the tone. So this is an apartment building directly across the street from my firehouse. We're right to kind of where the picture of us in the hallway is, which was taken, after overhaul of this fire. But it's real close. So as soon as we're dispatched, we've already got eyes on it as soon as the doors roll up. And we'll just go through from dispatch to how some things really changed on us really quick.
Engine 3, Engine 8, Engine 11, Truck 4, Rescue 3, District 1 Chief, Electronic Alarm, High Rise, F758, St. Michael Street, between North Scott Street and North Bayou Street, Map M10, Engine 3, Engine 8, Engine 11, Truck 4, Rescue 3, District 1 Chief, Electronic Alarm, High Rise, F758, St. Michael Street, between North Scott Street and North Bayou Street, Map M10, timeout 1339.
All right, so the reason I use the dispatch is, one, is to point out it did come out as an electronic alarm, but also that for us, that's a different companies. If it's an alarm, we're only getting the one ladder truck. As soon as they think it's a fire, we're automatically up in our companies, and we're getting more people. So it came in as an alarm.
Responding to 758 St. Michael Street, you're responding to Tower Ryan Park for electronic alarm showing general zone 993. Alarm companies attempting to contact the key holder. All units are assigned tax channel 1, tax channel 1. There are hydrants on side A of the building, 3 hydrants on side A.
It's work up. Alarm engine 3 on scene for a high-rise residential building. Nothing visible. We checking it out. St. Francis, man.
Very copy, say on scene 1341.
So as you can hear, we're right on top of it. As soon as they're given information, we're already on scene because we're just coming from across the street.
All responding companies, phone is 705-705.
We got inside, we went to the panel. They told us 7th floor. And as soon as we walked in the door, the building manager was telling us we've already got maintenance on the 7th floor. It's going to be this apartment. So we're letting everybody know where we're going.
For unit 3 to all responding companies, we've got sprinkler activation in the apartment at 705. We're hooking up on the 6th floor on the east side of the building. We'll be forcing the door.
So as we make our way up there, we get to the 7th floor. They weren't lying. They did have maintenance on the 7th floor, but this guy was literally just standing in front of the door of the apartment with water pouring out around the door from the sprinkler activation. So things changed for us pretty quick, right? We're trying to make sure everybody knows where we're going. If you notice what I said on the radio was, this is the apartment we have, and this is the stairwell we're going to be hooking up in. So we were already letting the chief know so he could declare his attack versus evacuation stairs.
We've got somebody in the apartment. We're pulling around now.
So we went in. It turned out, as you see in the picture on the right, the water can sitting there. Our trucks ride with 3, our engines ride with 3 for the most part, but our downtown engine rides with 4. So the truck boss is the one to my right in that picture. I'm in the middle. And he had a detail guy with him that day, and his job was the can, and he was walking up to the building from where they parked, and the boss realized he didn't have the can, so he sent him back to the truck to get it. When he heard where we were, we had sprinkler activation. He headed up a little faster than his guy who had to go back and get the can. So he made the fire floor right as we were forcing the door. And when he went in, sprinklers were going. They pretty much had it, but it was really blacked out. And he just, with my guys were stretching the line. He said, I'm going to go left. You go right. Let's start the search and make sure we've got the fire. So he went left, I went right, and we found a victim unconscious on the couch.
We need EMS to the 7th floor. We pulled the victim out. She is conscious now. She's at the elevator waiting on the EMS.
So we got her out. She ended up gaining consciousness a few minutes later and ended up complaining the whole time because we pulled her out without getting her dressed first. So, but just to show you, these things can go quick, just like any building. Always treat it, wear your gear, bring your equipment as if it's on fire. And keep in mind with these bigger buildings, sometimes they're going to hide things a lot better than just your standard house fire. They're a lot bigger of a box to fill before smoke's venting out, fire's venting out, things like that. So just keep that in mind. So as we get into it, and I'm not going to get into a lot of details on different types of wet versus different types of dry, just a basic understanding, right? You have wet and dry systems. So at least for me, with the environment I work in, we typically don't deal with a lot of dry systems. Where I work, I know dry systems for me are sports stadiums, parking garages, things like that for the most part. There's a few buildings we have that are dry systems, and they're open air balconies. They're not in a public hall, interior hallway. So typically when we deal with an occupied building, I'm working off of a wet system. So we can avoid dry systems pretty well. We'll talk about that in a minute, but we don't deal with them a bunch as far as our occupied buildings where I work. We're in wet systems. So just the basic understandings, the wet system, right? We've got water at all times. It's going to be our most commonly used. Like for me, I said it's pretty much all we use. We avoid dry systems almost exclusively. And it's used in heated buildings where there's no danger of freezing. So we get to a dry standpipe, right? It's not filled with water at all times. It might not have any other water supply other than you, but you also have to remember, you have to ensure all the valves are closed. So for me, like I said, it's parking garages mainly, and we have a very large homeless population, and they're in our run area. So what we deal with is people, the homeless, they go into the parking garages, they try to get water out of the standpipe for a shower or whatever, and nothing comes out. And they leave the cap off and they leave the valve open, and they go to the next one and try to get water, and they don't. And we end up with a bunch of open valves. So if you were going to try to use that system, one thing a lot of times we forget is the time, that reaction time, that reflex time of, as you start putting water in the system, the whole system has to fill before you can use it. But also, if you have a bunch of open valves and they're all just openly flowing, are you actually going to be able to achieve the pressure for your hose line without closing all those valves? And then to close those valves and ensure all the valves are closed, how much manpower are you going to have to commit to that? And do you have the manpower available to do that? So for us, just the way our buildings are set up with the fact that they're mainly parking garages and we're very, very much able to avoid them at most points, that's what we just do. We'd rather use a rope stretch or something like that than, you know, have to commit resources to closing these valves. So just doing a pre-plan. It was last year, the year before, we were assigned one of the parking garages. The way we assign our pre-plans, we had that one, and it's kind of the one we know. So we try to get out into about it once a month anyway, and just go close valves because we know it's kind of our biggest issue. That's where they're always closing valves on us and or opening valves on us. And as we walk through checking for valves, out of 30 valves, we had to close 16 that were open. Hold on, I see we got something in the chat. We got anything in the chat to answer right away? I can't open it, but I can see one popped up.
No, sir. I was just telling them if they have any questions.
Okay, it just popped up on a screen that there was a message. You hear my kid crying too much, or?
No, they're all good, sir.
All right. So, but keep that in mind. And there's just an example of one. It did have a cap on, but you know, they had left it open. So one of the things I try to point out is I'm not the huge medical run fan, is to make medical runs fires. Take the stairs down, look at the valves you have, where the standpipe's located. Are they in the stairwell? Are they in the hallway? Things like this. And it's talking points for you and your crew. And if you don't have a ton of high rises or standpipe equipped buildings, what it's easy to do is make things memorable in your mind. When you go into that building, you know. One thing I really try to always point out when we take the elevator up for a medical run, if we see a standpipe outlet right there at that elevator lobby, but there's no stairwell in the middle of the building with that elevator lobby, it's kind of a red, just a light bulb moment for us. And the reason being is, if you think about it, what's that standpipe outlet there for? Because we hook up on the floor below. So if there's no stairwell there, right, we would hook up to that outlet and stretch all the way to the end of the building where one of these stairwells are, and then go up. But there would be a standpipe there. So why would we stretch from that standpipe in the middle of the building to the other standpipe to go up, right? It's not something we would do. So why is that standpipe there? And what it comes into is it comes into NFPA 14 and the design of standpipes, and it limits how far standpipe outlets can be from each other. Okay. So as it does that, and I'm going to show you on the next slide exactly what it is versus sprinkler buildings, non-sprinkler buildings, and all that, you're looking at different numbers, right? So how far those outlets can be away from each other in feet. Well, if they had to put one in the middle, right, that's because the building's longer than that run distance allows, that travel distance. And that travel distance is a minimum of 130 feet, depending on how you read the code. But a sprinkler building can be 200 feet, right? If they're further than that apart, they got to put one in the middle to stay within the code. But now if there's not a stairwell there to use that one, this is a red light moment. Hey, light bulb, we could possibly have a long stretch here, right? So if you're always talking about that, you see the building, hey, this could be a long stretch. It's just easy to remember for your guys. So make those medical runs, you know, about fires. So here's just how the travel distances are written in the two codes. Everybody probably knows there's two versions of the standard with big differences, right? Pre-93 and post-93. We'll really hit on the big differences of those later. And I'll drive this point home there too. But keep in mind, you have to remember that the 1993 aspect of that code change is when NFPA changed the standard. When it impacts you is when your city adopted the standard, right? So if it was changed in 1993, but your city didn't adopt the updated version until 1995, these changes impact you in 1995. So a building built in 1994 would still be pre-93. So always keep that in mind, right? It's not just when NFPA made the change, but when your city adopted that change. Okay. So if you look at it in the pre-93, it's all portions of that floor of the building are within 30 feet of a nozzle attached to not more than 100 feet of hose, right? So 130 feet. Then you get to the post-93 version and you have, shouldn't be more than 100 feet or 130 feet for non-sprinkler buildings. But now when you have a sprinkler building, it's allowed to be more than up to 200 feet apart. So now think about it. You have a sprinkler building in a post-1993 design, and there's a standpipe outlet in the middle of the building with no stairwells. You could have a very long stretch. And these are things, if we can remember them in the forefront, because we talk about them on those medical runs when we're constantly in these buildings, we can remember it when we pull up. It sets us up for success. All right. So when you pull up, you know, we're typically used to house fires. So you pull up and you go, I've got a 2-story or I've got a 3-story. I got fire out the windows on the 2nd floor, right? It's easy to just count floors. Don't just count the floors and say the fire's on the 16th floor in one of these taller buildings, because one, all the buildings can be labeled different, right? The floors. So if you look right here, we're looking at 2 very similar buildings in my run area. They're the same size. One's got 1 extra floor, the whole deal. But look how they're labeled, right? They're labeled different. The one on the right is 1, 2, 3, 4, 5, all the way up to 10, and then the penthouse is 11, right? But then when you come over to the one on the left, you have the 1st floor is ground, the 2nd floor is 1. So if you start just outside, you see where the smoker fire's venting, and you label that floor on the radio. Everyone's got that in their mind, and that's where they're going. And you could send them to the wrong place, right? A lot of buildings don't have a 13th floor. It could be ground, then 1. You could have a mezzanine. There's a bunch of different things that can play in here in the way a building's floors are laid out and numbered. So go to the alarm panel to get the actual number of the floor before you put that on the radio. So just like that, make sure you get inside, you get to that fire alarm panel. You want to confirm the alarm location, and you also want to scroll for that initial alarm. Okay. The alarm panel is only going to show 1 alarm at a time, and that's going to be the last one that activated. Okay. So you want to scroll those alarms and figure out where the first alarm to activate was, because that's going to be closest to your seat of your fire. And when we talk about tenant stairs in a minute, you could have fire on multiple floors and the smoke traveled up. Okay. And now what's the last alarm to go off? That's the one that's showing. It's on the upper floor, right? But your fire might have been on the lower floor, and now you're going to commit to the wrong position. So I'm going to show you something with this fire. We'll listen to some radio again. And it's just how some things you have to get to that alarm panel and confirm what you've got. Okay. I used this picture. It was in the 40-story building in the background, but I used this picture because we were standing on this corner when this came in. We were doing our hydrant inspections for the year, and we were inspecting a hydrant sitting right on this spot. When it came in, it said 11 North Water Street, and we just looked up. So this was our view when the alarm came in.
Engine 3, Engine 8, Engine 11, Truck 4, Rescue 3, District 1 Chief, Structure Fire, Highlight Hazard, F11 North Water Street, between Dawson Street and St. Francis Street. Next.
Okay, so in the dispatch, what I said with the other fire we listened to, right? If it's a high rise, we get a 2nd truck. They dispatched it wrong. They dispatched it as a structure fire with high life hazard, but not a high rise. So they didn't automatically send the 2nd truck. They ended up correcting it pretty quick, but it was sent out with the wrong dispatch to start. So you'll notice as soon as they give, I'm going to give an arrival report because we were literally a block away. And then she's just going to follow it up with the information. She doesn't even get information to us before we're on scene.
Fire alarm engine 3 is on scene with a 40-story high-rise office building. Visible. Be checking it out. This will be St. Francis Command.
District 2 on scene with nothing visible, 919. All units responding to 11 North Water Street for RSA Tower. You're responding for heavy smoke in an IT room. The room is possibly on the 8th floor. The alarms are sounding. Occupants are evacuating the building. All units are assigned TAC 1, TAC 1. Hydrants are going to be on the Water Street, St. Francis Street, and second hydrant is on Dawson Street, Water Street. Yeah.
All right, so now it's easy to get pulled into that. She told you it's in the IT room, 8th floor. 8th floor happens to be the floor we go to almost every day in this building. It's where they've got a lot of their mechanical rooms, and we deal with a lot of smoke alarm activations in that floor. So it'd be easy to take that information and go and just go to the 8th floor. It's where we usually go to. She just confirmed it by saying 8th floor. Okay, but you go to the alarm panel, make sure you know where it is.
Go ahead. We're making it to the 20th floor now. That's where the fire is. Let's check it out. We got 4 with us. Send 8 to the 19th. Stairwell 1.
Right. So things changed pretty quick by getting to the alarm panel. They told us the 8th floor, the fire was on 20. Okay. So we had to get up there again, which stairwell we were in. We get 2 engine companies to every line. We were up there with the truck already. Send engine 8 to the 19th floor. We're going to be in this stairwell, right? It changed pretty quick. What happened was the person that called and saw the alarm was in the room on the 8th floor where they have an alarm panel. They called it in. The dispatcher said, where's it at? I'm on the 8th floor. So it mixes up information. It's just a lot of ways things, it's a big building. Get to the alarm panel, see where you need to go, and confirm the location of that alarm at the alarm panel before you go up. So you don't commit your resources to the wrong place. If we'd gone to the 8th floor and then the next companies went to the alarm panel, this wouldn't be our fire. I mean, we'd be out of the equation. We'd be embarrassed. Just go to the alarm panel, know where you're going, commit your resources where they need to go. All right, so here's the tenant stairs we talked about, right? It's a set of unprotected stairs. It's going to connect multiple floors, and it can, because it's unprotected, it allows fire and smoke to travel vertically in the building, right? So when you think about it, we have some that are commercial, we have some in hotels, we have some in residential apartment buildings. All it is you own multiple floors. So we have some, one of the residential apartment buildings we were in the other day, like they have the 16th and 17th floors. If you have apartments on those floors, you have both floors. So their living spaces, kitchen, living room, all that is on 16 and the bedrooms are on 17, right? And they have an open stairwell in the middle because they wouldn't want you to have to go out to the elevator lobby or the building stairwells to go within your apartment. They give you your own stairwell in your apartment, just like a house. Same thing with commercial buildings. If you own a company and you have a very large company and you buy multiple floors of a building, you're not going to want your people that are on the 15th floor to have to go out to the elevator or the main stairs of the building to get to the 16th floor for your meeting. You'd put your own stairs into the floors you own so your people can traverse your own floors within your part of the building. And then you create this ability for smoke and fire to travel vertically in buildings that aren't designed to allow, by their design, right, fire to travel like that. So what that does is it gives that ability for those alarms when you check the panel to be showing the wrong spot, right? So if this is in a hotel presidential suite, and I can't think of the floor right now, but I think it's like the 13th floor, 12 and 13, something like that. And so if the fire started on 12, right, but the smoke's traveling up these unprotected stairs, that last alarm to show on that panel could be on the 13th floor, but your fire is actually on 12. So if you don't scroll the alarms and see where that original one is, you could be committing your resources to the floor above rather than the fire floor. So take the time, get to the alarm panel, check and make sure where that initial alarm actually activated at. Okay. And then when you get in these buildings, it's not just like houses anymore with straight run stairs, or even if it does have a turn to the landing, it's an open set of stairs. You're operating in a enclosed staircase. Okay. You're operating in a staircase that has its own concrete enclosure. And you got to understand a few things with these stairs, okay? How they're laid out, the design of the stairs impacts our stretch and impacts our orientation within the building. Okay, so you have two main types. You have return stairs and scissor stairs. Return stairs, what we're looking at here is what most people are typically the most comfortable with. It's what they see the most, and orientation is very easy, okay? Because as we look at it, so you've got a picture on the left of a return stair. You've got a picture on the right of return stairs with some hose laid out in it. And in the middle, you've just got a little diagram of how it's laid out, right? So if you're looking at these buildings, you might have the elevators in the middle, but on the end, you have your stairwells. So you have a concrete enclosure on the east side of the building with a stairwell, a concrete enclosure on the west side of the building with its own stairwell. Okay. And you go up, 7, 8 steps, you hit the landing, you turn around 180 degrees, 7 or 8 steps, you're at the next floor. And all the doors to the hallway line up, or to the commercial space line up above each other, right? They're right where those numbers are on the left in these stairs. So you always enter the building outside, out of the stairwell into the hallway or the office space in the same spot in the building, right? So it's really easy to poke your head out on the floor below of a residential apartment building, look, say, okay, 503 is the second door on the left, so 603 will be the second door on the left. And your orientation is easy and correct, right? You knew where you were in the building. But what it does for our stretch, it's got a benefit to the orientation, but with our stretch, it adds an extra set of turns in every floor you have to go up. So if you have to stretch hose around these stairs, it's going to use up a lot of hose, a lot of time, and a lot of people. Okay. So it does have its benefit with orientation, but if you have to stretch around these stairs, it's going to take a lot of people. So this is just how they're laid out. There's 228. You go up, you hit the landing, you're going to turn around, go right back where you came from. Right? You're right back above where you started at. You get to the 3rd floor. And when you look out the door, that first room is going to be right above where you were. It's 328, right? So we turn around. When we go to the 4th floor, it's going to be the same thing again, right? Unless the size of the apartment's changed, your numbers are going to be pretty close. They're typically going to mirror on each floor, as long as there's the same number of apartments on that floor, right? So 428. So our orientation was very easy there, right? It was easy to be able to know where you were by looking at the floor below. But then you get to scissor stairs. Okay, so both pictures on the left and the right here are both scissor stairs. Okay, but the one on the left is in a convention center, the one on the right's in a hotel. In the convention center, they could really care less if you see the person going down the other set of stairs while you go up yours, right? But in that hotel, they do care about aesthetics. They care if you see people in the other stairs. They see if you see the other stairwell. So they put a wall in the middle. But instead of having both stairwells on the ends of the building, right? And it's a stairwell on the east end, stairwell on the west end, and its own stair concrete enclosure. Now, just like the elevators in the core of the building, they put the stairs in the middle, right? So one concrete enclosure, both sets of stairs are just going to crisscross like you see in that diagram. Okay, so they save some space that they can rent out on each floor, right? They're still required to give 2 means of egress on each floor, and they did. If this was the fire floor, right, you have one here and one here. They're just pointing out to different sides of the building. So you have your 2 means of egress. Okay, and they crisscross with any in that concrete enclosure. So the black line is one set of stairs, the red line's another within the same concrete enclosure. But what you notice is there's no turn at the landing. You might have a landing, but you're not going to turn. It's going to be a straight run of stairs. Okay, so when you look at your hose stretch now, the benefit is less turns. So less pinch points you have to manage and commit people to. But our orientation now is not as simple as it was with return stairs, right? Because if we were on the stairs that are diagrammed in red, okay, and we'll call the right of that diagram the east side, the left of the diagram the west side. So you got in the stairs on the first floor on the east side of the building, but when you come out of that stairwell on the second floor, you're now facing the west side of the building. Your orientation's backwards. You're on the wrong side of the building, right? But then when you get to the third floor, now your orientation's correct again. You're back on the same side of the building that you entered the stairs on, right? So if you recognize scissor stairs, you'd want to check the floor below for the layout, 2 floors below, not the floor below itself, right? We always say floor below, poke your head out on the floor below, see where the apartment is. So now you can count doors. If you have scissor stairs, do that 2 floors below so your orientation's correct, right? So you don't want to you're on the wrong side of the building and now you're completely turned around. You do it 2 floors below, you'll recognize where you are. If you get on an elevator, get off the elevator 2 floors below. It doesn't matter if you have scissor stairs or return stairs, your orientation's correct. You'll be getting into the stairwell on the side of the building you want to, which means you'll exit the stairwell on the side of the building you want to. So before I move on, I just want to make sure everyone understands that. Just make in the chat, just a thumbs up. Make sure we're good on that. Because I know scissor stairs can be confusing for some people because they don't deal with them a lot.
Yeah, Captain, while everybody's answering, can you specify maybe some ways to identify scissor stairs other than just your, getting out to your buildings or signs, maybe like that they're longer runs or different things?
When you get in the stairs, if you see that straight run like you see on the right picture right there, there's no turn, and you're in the center of the building, you're going to be in scissor stairs. You're going to have that. You're going in on one side of the building, you're coming out facing the other. So you're just recognizing, do you have turns at the landing or are you running a straight run? If that makes sense.
Yep. And sounds like we're understanding it in the chat as well.
All right. So here's a video just to demonstrate it, but I wanted to make sure before I played the video, if anyone had questions, we could handle it. Right. So here's 804. This is a round building, so it's a little weird in the video. Okay. But you go up the stairs, you recognizing that straight run, right? So you never turned around to go back into the direction you came from. So when we get to 9, now you're looking at 9, 10, and 9, 11. Like I said, the apartments are laid out a little weird, or hotel rooms, because it's a round building. But now when we get to 10, we're going to be right back where we started, right? So now my orientation's correct from where I got into the stairwell. Okay. So it's just going 2 floors below instead of 1. It's just recognizing you're not turning and coming back the direction you came on a half landing. You're doing it on the next floor's landing instead. All right. So like I said, we avoid using the standpipe, and I'm the standpipe guy for my department. I've studied them. I've worked downtown my whole career. I'm on the standpipe committee for NFPA, but if we can avoid them, we do. We try to stretch a line if we can. because we have more control that way, right? We check the rig off in the morning. It's our hose. We know it's maintained. It's not relying on a system to start. It's someone putting it in pump gear and they checked it that morning. It's not hoping that the building was maintained correctly and the city kept up with it. I know who maintained that truck, that hose, the nozzles, everything. So we just have more control over the situation. So if we can stretch, we stretch. And one of the things we do is check for a well hole. We get in a stairwell, we look up, we see a well hole, which is that space between the railings and the sections of stairs. Then if we can, we'll use it, especially for the lower floors of the building, just to maintain control rather than getting into using that standpipe system. So a few things we look at though, the one on the left versus the one in the middle and the right, which is the same one. One big difference is just pure size, right? I look at the bottom, I get to the bottom of that stairs on the left and I look up and see that. I know the hose fits. Now I do want to look up and make sure that well hole goes all the way. I don't want it to terminate after a few floors and the stairs got tighter. Now I committed, I called for a shorter stretch than I actually need, and I'm going to stretch short. So I want to make sure it goes all the way up. But on the smaller, narrow well holes, I want to do the same thing. I want to look and make sure it goes all the way up. But now I'm not 100% sure the hose is going to fit. I just take my glove fist, put it in the well hole, move my hand around. My hand moves, those couplings will pass, and we can do the stretch. So this is how we do it. We're able to film it. We get a lot of rookies in our station because it's one of the busier stations. It's one of the things we always do is go into these buildings, teach them how we stretch in certain buildings, right? So he's going to make sure that hose gets into the well hole. Someone's going to just stand at the bottom and pull slack to the well hole so he can just walk up the stairs. He's holding the hose in the middle of the stairwell just so the couplings aren't catching because it's tight, and pulling it. He keeps the hose on his shoulder on the opposite side, so if the couplings did catch and kind of pull the hose, he doesn't risk the hose falling off his shoulder into the well and losing it. Okay. So that's how we take hose up the stairs for a well hole stretch. Just showing you how we do it. So now when we get into the standpipes, okay, so if you look at NFPA 1710, and I've never really understood why NFPA does a standard as far as staffing for career versus volunteer fire departments for when they classify how many people should be a different type of building fires, because I don't really think it changes, right? Whether you're career or volunteer, I think that if you say this many people for this type of building, it probably doesn't change. But if you look at it, right, most fire departments probably do on their first alarm either hit or come close to single family dwellings, open air strip malls, and garden style apartments with getting the right amount of people according to NFPA on scene. But then you look at that high rise number, how many people are getting that many people on their first alarm, right? I know my department's not, we're in the 20s, right? So what it does is it makes us just remember we have to be quick to call the second alarm, right? We know we don't have enough people from what everyone's experience and studies say we should have. So if you do have something, get it started quick and get that help coming. For someone else, that might be mutual aid. For us, it's just the second or third alarm. But get that help coming your way because you have reflex time. You got to wait for them to get there. Get them coming. You know you need more people for these. Okay. They also did the study NIST did, I think it was like 2013, on staffing for high-rise building fires, right? And what they found was they looked at a bunch of different tasks, like 16 essential tasks that got to get done at the fire and everything. But just looking at advancing the hose line, because that's if you're operating off the standpipe, that's your job. Get that hose line in place, right? So if you had a staffing of 3, right, you're 8.5% slower to get that line in place than if you had 4, 13.9% slower than if you had 5, and 22.3% slower than if you had 6 on that crew. Okay. But they also found that if you have a low alarm response with crew sizes of 4 and 5, you're going to outperform a high alarm response of crew sizes smaller by that one firefighter, right? And that's what I deal with is we'll just send a lot of companies. They just have less people than having less companies go that have more people on the rig. And the reason it's more effective to have less companies, but more people on each company is you're not having that reflex time of having to wait as long for that staffing to arrive. You're able to get things going a lot faster, right? So those are just a few things with some understanding staffing and how it's going to impact you. Get that help coming, right? These take a lot of people. Get that help coming quick. Okay, so like I said, we like to avoid it if we can, and we stretch from the street when we can, just for control. We have more control over the operation, like I said. So if we can use a well hole, we will. Like I said, we avoid the dry standpipes. It's pretty easy for us because it's open air balcony buildings and parking garages. We can drop a rope, things like that, and stay in control of the operation more by doing that than using that dry standpipe, having the time delay of filling the whole system, worrying about maintenance of the system, and then also how many of the valves are open, and we need to commit people to go close them. If the fire's on the lower floor, we want to stretch. If it's on the ground floor, second floor, we're stretching from the street. Definitely if it's in the basement, we want that line to take us either off the fire floor and down, or if we went to the basement, we want to bring it all the way up out of that stairwell, because if we had to, evacuate, we're going to be in that vent. So we want it to take us out, not just to the stairwell where everything's coming to. And then if we've got a well hole, we'll use the well hole as well and avoid the standpipe system when we can. Right. So this is how we rope stretch.
Hey, Captain.
Yep. Go ahead. Go ahead. No. No, I lost your audio. I'll text you real quick to get the question.
Is when are you off to stretch? Can you hear me well?
Yeah, I just got your audio in.
Okay. Yep. So when are you stretching from the rig, and then versus the standpipe, as well as when are you stretching at 2.5 or 1 3/4?
Okay, so like I said, so if we go back, this is kind of where we're going to stretch from the rig pretty much anytime we can. Like I said, but for other people, the dry standpipe might not be as easy, right? For us, it's easy because our occupied buildings are wet, other than a few, and those are open air balconies that we can easily drop a rope and just avoid the system. We just know in our city, the dry standpipes aren't maintained very well. A lot of the valves are usually open from homeless people and things like that. If it's on that first, second floor basement, we're going to stretch from the engine. And then if there's a well hole, especially lower floors, and there's a well hole, we'll stretch from the truck. So what we use for these is we use our bulk bed, which is a mixture of 1 3/4 and 2.5 for residential, like you see here. If it's a residential fire and it's in the apartment, it's not out in the open, in the public hallway, it's not wind driven, we'll use that line. It's supplied by it's got 2.5 in it for less friction loss, but we'll use that 1 3/4 line for the apartment. If we were using a standpipe, we're not allowed to use 1 3/4 due to friction, but off the rig we can in that situation. Anything commercial, we would use all 2.5. If it was in the public hallway, we use 2.5 in my department. But that's how we kind of dictate which times we're going to stretch off the rig and which line we're going to use. There's a few buildings we have that we just know we're kind of going to stretch and go to a well hole, even to go pretty high in the building. And it's just, it's some really bad situations with lack of maintenance with fire pumps. If you know where we're situated at, we're right on the Mobile Bay, right on the Gulf of Mexico. We flood all the time. And like we've got one building, it's a 12-story non-sprinkler commercial building. It's half a block from the bay, so it always floods. And the fire pump is in a vault underneath the sidewalk, and the vault's not watertight. So the fire pump in there, literally we found it. We started reporting it years and years ago. Nothing happened. We finally got a new fire marshal, and they started looking into it. It's in court right now as to who's going to have to fix it. But the testing company wasn't even comfortable enough to try to get the fire pump to start. They felt like it would crumble and they could possibly get electrocuted. So it's in that bad of shape. It hadn't been tested in 15 years, and it's just a pile of rust. So a building like that, we just know from pre-planning, we're going to have to stretch that building. We know the fire pump's not going to run. The piping from the FTC is also in that vault, so it's in pretty bad shape as well. So we don't really expect any type of system help in that building. But pretty much anywhere else, it's going to fall into these three, unless just something, you knew from pre-planning or something like that. But that's kind of how we do it. And then our 2.5 versus 1 3/4 being residential versus commercial, and residential being in the apartment, not out in the public hallway, and not an indication of wind driven, if that answers the question.
Yeah. So even on say they're like 3-story apartments on the top floor, are you more likely to take a 2.5 with the?
Yeah, we would take that bulk bed, and if it was just in the apartment, we'd take that bulk bed. Ours is 200 feet of 1 3/4 to 300 feet of 2.5, and that's what we would use.
Okay. And then
unless it's just we have some buildings where the distance from where we can park in the street to the stairwell is extremely, extremely long, which is not normal for us because we're such an old city that we go in most apartment buildings, the stairs are kind of right there at the door. For us to have these stairs, we have to go kind of a long way, like newer hotels and stuff. It's kind of rare for us. And we consider the standpipe on lower floors in situations like that where it would just eat up a ton of hose just to get to the stairs before you even start going vertical. But typically for us, we can either go in the door where we're pretty close to the stairs, or it's like this where we're right where that W is on the door for the west stairwell. There's a well hole, so we're 15 feet from the well hole, and we're already going vertical.
Okay. And then I got another question for you. So, as far as well hole, yeah. And then, so as far as well holes or like flying standpipes, are you comfortable flying couplings, or are you maxing that out at like the 50 feet to?
Yeah, so the flying standpipes, funny because I wrote an article on it one time and got taken really out of context. We do the flying standpipe for ship fires and stuff because we're first due at the port, but we typically don't do it for buildings. Yeah, we'll do a lot of stuff hanging rope vertical, whether it's rope stretch. We'll have the tower ladder for some stuff, move equipment up there and then they'll lower hose down if they had to. We're typically more going to use a rope, but we do go vertical with our hose in that sense. And we're about to show you how we do it for our ropes, but we do hang hose vertical, typically through a rope stretch. Was there any more questions on that?
No, sir. That's it.
All right. So when we do our rope stretch, I always like to show this picture because what's on the left is kind of what our training staff has. The hose roller we don't have in the field. We only have them at the training center, not for the companies in the field. So we have to do a little bit harder of a transition over the edge of the windowsill or whatever. This is just the old hose tower of our firehouse. It's a stairwell now. So we're able to let guys, when they're new in the company, get out there, just go up there and work on rope stretches and all. And then, like I said, I've worked in that firehouse a long time. So by doing that, I've been able to make a lot of good relationships with building owners and managers. And then we have a lot of places that let us train in their buildings. So our guys get to go out and actually do this stuff to learn a skill, not on a drill tower, but in the building they, might have to make a fire in. So, but the way we do it, if it's going into into the building, it's going in interior building, public hallway, interior hallway type building. We enter on the floor below, through a window, and then it's just like a standpipe. It's on the floor below. We make our way up. Our department lets us, if it's an exterior open air balcony, stretch the line to the fire floor, vertically, bring it over the railing of the balcony, and then we're on the fire floor not hooking up, but where our line is versus being the floor below like a standpipe. And the reasoning is that you're outside. So if you came out of that hotel room or apartment, whatever it is, you're already outside. You can go either way. It's not like a public hallway and you need that hose line to necessarily, track you and find your way out. And then we tie the line off. So this is how we do it. He's not really that fast. It's kind of sped up, but if we were coming in from the floor below. So this is the way we would do it. We raise it with a rope. We're actually transitioning to just using a carabiner instead of knots now. And we try to load 100 feet on our shoulder. So it's just like if we stretch dry. It's just like if we came off the rig with our 100-foot Minuteman. Our 100-foot Minuteman bundle. So he gets it untied. He's going to load 100 feet on his shoulder. And if you notice, we mark all our midpoints, not just standpipe hose, but every hose we have. Don't mind the truck boss that just walked in. He's my buddy, but he can't help but try to help. So he's gonna help him here in a second. There you go. So he gets his 100-foot, and then the way we do it, he's gonna reach back and he's gonna grab that midpoint marking of that third length and bring that up with him. And he's gonna try to get that midpoint marking up to the top of the stairs so that now he knows he's got 25 feet from that to get to this, out of the stairwell or into the hallway. And then he's got his 100 feet of hose. So he's going to go out, get to the apartment, lay it down, and he's going to split his bundle, and he'll be laid out, committing 50 feet to the apartment. So that's how we do it. If we're going to a public hallway, we're going interior in the stairs. If we're going to an open air balcony, we do it like this. We'll go to the fire floor. He hands it off. He tries to step out of his way so that guy can keep pulling hose up. He's not worried about hitting him and get it untied. Once he gets it untied, he's just going to stretch it out and get his 50 feet for that apartment. And that's how we do our two versions of rope stretches. We're currently going through the process of changing it out and getting rid of knots. and just being quicker, having a carabiner instead of lowering the bag, lower the end with the carabiner on it, just clip the bail, raise it up, and then you still got your rope if you needed it for something else as well. So if you have to pump the system, and a lot of places do this different, right? Some people pump the system no matter what. We don't. If we were to hook up to a dry system, obviously we would pump it. But when we're in a wet system, which is what we're typically in, we don't automatically pump the system. We kind of modeled after Houston. It's a command decision to actually pump the system, but that doesn't mean our trucks are just kind of sitting there. Every connection is made, and they got water flowing from the hydrant to the pump, to the first pumper. He's pushing it to the second pumper. They're just kind of at idle. And then the lines are hooked into the building. They're ready to charge the system if they're given the order. And the order always comes from command if they're going to put water in the system. And that's just how we do it. We have some buildings that they need a lot of pressure, up over 400 PSI. And we don't necessarily have trucks designed for it necessarily. All of our stuff's single stage. So we're putting trucks in series to do it. We don't have a truck that it's going to put our trucks kind of running at their capacity sometimes to do it. So we don't try to make the pumpers do it when the fire pump can. So we give the fire pump the chance to do its job. And then if it doesn't, then we'll take over. And that's just how our kind of books are written on how we hook up to a system and get ready to pump it, because we don't automatically put water in, but we're always getting ready to. We have a pumper at the hydrant, pumper at the FDC, everything's hooked together, and we got lines to the building. So it's just a matter of the command gives the order to put water in the system, and the two drivers start flowing water that way. But when you get to the FDC, we've got to figure out, it's easy to read signage, but it's not always there, right? So at night, it can be hard sometimes. And like this picture on the left, all that signage right there, when they painted the building, they chose to paint over it. So now there's no signage. So you need to kind of know what you're looking at. In the one on all of them are the same, right? They've got FDCs and they've got test heads, just different designs of test heads. The one on the left is the easiest one to determine, right? It doesn't even look the same. You got a Siamese, and you got a test head with multiple heads sticking out off of it in different directions. It doesn't look like something you're used to hooking up to as an FDC. But then you get to the other two, you can start having problems, right? If you don't know what you're looking at, you could try to hook up to a test head versus the FDC itself, right? So remember, your FDCs have females, your test heads have males. All right. Another thing is, when you look at the picture on the right, there's two different FDCs, right? You have the test head on the left in that picture, and then two different FDCs. One's a dry standpipe for the parking garage, one's for the building. So you got to know what you're hooking up to. You can also have different locations around the building where the FDC connections are. So like in the picture in the middle, there was a fire 8 years ago, 7-8 years ago, on the 34th floor. The order was given by the chief to put water in the system, and that outlet right there was hooked up to. That goes to the parking garage, not to the building. So had the fire pump, this was before we didn't put water in the building at every fire. Had the fire pump failed, that water wouldn't have went where it was needed. It was the wrong area of the system. So it was a sprinkler system for the parking garage and standpipe for the parking garage, but not the standpipe for the building. So keep that in mind. Always kind of know where it is. That's pre-planning. That's learning your buildings, but also taking the time. Just pay attention to what you're hooking up to. Okay. You also got to deal with this if you have these in your buildings, and there's multiple reasons it could be there. So as you look at NFPA 14, and we'll hit on the stuff that everyone focuses on with the pressures at the outlets, and that's what people pay attention to. But also understand that in that standard, it says there can't be an outlet anywhere that there's more than 350 pounds of pressure in the system. Okay. So like in this building, because of that, you have two separate zones. You have a low zone and a high zone. So that there's no outlet where it's not allowed to be. There's also a way to avoid having pressure reducing valves in your system by just having risers that don't go above 175 PSI, or let me rephrase, no outlets located on a riser in an area where there's over 175 PSI, which would just, the way you could do it, not a lot of places do it that way, would just be to create multiple zones so that there's different zones, and that's where the pressures are. But here in this building, on the left in the picture, all the way to the left is the low pressure or the low zone of the standpipe system. Okay. It supplies the basement and floors 1 through 7. And then in the middle is the high zone. It supplies floors 8 through 40. Okay. So if you were to hook into the wrong one, if we were hooked up on the 10th floor and you needed to pump the system and you hooked into that FTC on the left, your water, if you look at this picture on the right where that outlet is and it's got a cap at the top of it where that riser terminates, that's where your water is going to stop because you put it in the wrong part of the system. Okay. Same way, if we were in the low zone, right, and we were hooked up on 6 and you hooked up to the high zone FTC, that pipe on the right in the picture of the stairwell, that express riser that's bringing water up for the high zone is where your water is going to go. It's going to bypass right where we are and where it's needed. So again, pay attention to where you're hooking up to your FTCs. Pay attention to these things on pre-planning so you know your buildings if you run into this. But just pay attention to where you're hooking up to your FTC and make sure you're putting your water where you want it to go. So as we do it, we get into pumping a system. It's different if you're pumping a system and they're hooked, the line's going to be hooked up to a PRV versus the line's going to be hooked up to no PRV, just a standard valve. The way we have to pump that system is different. Okay. So if there's no PRV, you're just pumping to the floor where they're operating, the floor where they're hooked up, right? I need to get, for us, we pump to get 100 pounds to that outlet, right? So 100 pounds to where they're hooked up is my goal. So 100 pounds, head pressure, and we're good to go. Okay, but if they have a PRV, you have to remember that PRV, it's going to reduce pressure. It's set to reduce a certain amount of pressure, right? And it's not going to change because you don't have enough, you're not giving it the pressure the system's designed to give it. If you give it less pressure than it's designed to have, it's still going to reduce the pressure in the amount it's supposed to, percentage-wise, however you want to look at it. Okay, so you have to put on the back side of that valve what the system's designed to put on the back side of that valve. So you have to pump the top of the zone. So if you don't have a zone system, it's a single zone system, you're going to pump all the way to the roof, regardless of what floor they hook up on, if they're hooking up to a PRV. If you're in a multi-zone system, so we go back to this, if I'm hooked up in that high zone, even though I'm hooking up on the 20th floor, they have to pump to 40 because that's the top of the zone. And that's what's going to put the right amount of pressure on the back side of that PRV. So once it reduces the pressure down, I'm still getting out what I'm supposed to get out. All right, so this is how we pump it. And I'll go through the math kind of easy for you. It's not difficult. It's just odd to some people how we do it. But we just use a chart so that they're not doing math on scene. And we're actually even getting away from this to where, which floor were you hooked up on? They find that floor. Okay, they're hooked up on 13. It's within 1 to 15. They pump either 175 or 205 based on residential and commercial. And the reason those are different is just we studied our city. We know our residential high-rise buildings, the average floor height is 8 to 10 feet. So it falls within that normal 5 PSI per floor, but our commercials average 14 feet per floor. So we adjusted our math to be 7 PSI of head pressure per floor to account for that. So that's why those numbers are the way they are. What we actually did is I was part of a committee. They actually sent us out and we did a bunch of really in-depth high-rise surveys for every high-rise in our city. We're going to up all of our buildings to the newest standard of NFPA 14, which actually has labeling at the FDC of what you should pump the system at. We only have one building new enough to have that. All of our buildings are, for the most part, pretty old. So the city's just taking that on. They're going to up the standard for ourselves instead of requiring building owners to do it, buy placards and placard all those buildings. So we had to go out and just figure out what we had to pump every building. So part of those studies was we went out and got the churn pressures of every fire pump so we could do that. So it's going to be labeled on the building, on the dispatch information, in the MDT, on the CAD information, as well as the chiefs will have a book that just they can flip to, and it's got all the high rises listed, exactly what to pump each building at, just to kind of take any estimation guessing out of it and make sure that we get it right. So we try to always get someone to the fire pump room. Even if it's running and we're doing good, we get people to the fire pump room for a few things. One, just to get eyes on it. Look at the fire pump room, look at the fire pump, see what kind of condition it's in. And that can tell you kind of, do you have faith in it that it's gonna work, it's gonna survive the duration of the incident. If you get in a fire pump room and it looks like this, you can see the bucket underneath the fire pump catching water that's leaking. There was oil dry everywhere. There was sandbags trying to keep the water in. Then you walked over, you looked at the inspection tag. I think I took the picture in like 2019, and it said the estimated life of the fire pump had expired like 22 years before that. So you would sit there and say, we don't expect this fire pump to do much for us. And maybe we make the decision to just pump the system, turn the fire pump off and take over. right? But we want to make sure it's running, check the condition of it. And if it didn't start, maybe it just didn't start automatically. You might be able to just overcome the whole thing by switching the fire pump to manual and starting it yourself. So a bunch of benefits by getting someone to that pump room. For us, because of manpower, we don't have those 40 and 50 person alarms for a high-rise building. We're coming with 20 in the 20s. We're going to call the second alarm, and they automatically send whoever from the Bureau of Fire Investigation and Prevention, because it's the same division for us, that's on duty. We've always got an investigator on duty. They're the ones that the chiefs are going to send to the fire pump room. Since they have training from being in the Bureau, they can trust that they all know what they're looking at and things like that. So they try to get them to the Bureau, to the fire pump room for us. We could take our break now. That's fine.
Okay, sounds great, everybody. We will take a quick 5-minute break, empty the system quick, refill the drinks, and we'll get back in 5 minutes. 8:06.
All right, sounds good. A little bit. Mainly Hayden crying. Breakfast.
All right, everybody. All right, Captain, we're gonna. That's
Hold
it.
on. I'm gonna have to unshare my screen for a second and share it back because I had the chat up to see what I needed to address, and for some reason it froze in the middle of the screen.
Oh, okay.
All right, hold on. All right, you got my screen back?
Yes, sir. Yep.
Let's see. All right, so the only thing I saw, I tried to get out of it as soon as it started freezing up, and just I didn't want it to freeze the PowerPoint. The only questions I really saw to go over before we go further is the stuff on churn pressures. Is that the only ones? So I saw a couple in the chat, but I didn't open the Q&A, and I see a bubble on that now, but I don't want to risk freezing the PowerPoint.
Yep. So it's the same one as the churn pressure.
All right.
So
I'll do it.
What's that?
I'll cover it when we get everybody back.
Okay.
Or when you're ready to start again. I didn't even.
Yeah, we're ready to start. So I'll go ahead and ask them for you, and then.
All right. So going back to the pressures. So what we did was we labeled churn. What the newer NFPA standard is putting on there is basically the same thing, but it's just labeled in the standard as system demand pressure. And what the churn is the highest amount of pressure that pump can put out. So what you have to keep in mind is with a fire pump, as you limit the water coming out, the pressure increases. So you want to get the churn pressure because that's the max the fire pump could put out. So like when I say we have a building that requires over 400, so the RSA tower, which is where we had that fire on the 20th floor, it requires 440. For us, that's what we pump it at. It's its churn pressure, but its normal daily operating pressure is 380. So it's not a churn isn't what it's usually running at. It's the max that pump would put out, if that makes sense to everybody.
Yeah, and hey, real quick, Captain, can I just ask you the questions real quick, just so we have it on audio in case
Yep.
in the future can't see the chat.
Okay.
So the questions were: can you talk a bit about pump churn pressure? And then
Yep.
a follow-up question from somebody else was wondering if signs posted at FDC with churn pressures is required now in an FPA 14.
Yes, it is. Which it's labeled the system demand pressure, but yeah, it's required in signage now of what to pump the system at. So like for us, when I said we're taking that on ourselves, we have one building new enough to be within that version of the standard, and it's a federal courthouse, so they obviously we're going to follow it and did it anyway. But the rest of our buildings are old, so they didn't have that. The city is trying to be more business friendly, so they didn't want to require really anything from a business owner, even though it would be cheap to put a placard on them at the FDC of what to pump it at to make sure we got water if they had a fire in their building. But they didn't want to risk pissing off building owners right now when they're trying to be more business friendly. So the city just took it on to say, we'll foot the bill. We had a good couple years. The port is growing like crazy and bringing a ton of money to the city. So they said, we'll just spend it on that. And they're gonna pay the bill to placard any building. We have to pump over 150. So what we're doing is we're going to make it to where for our older buildings, because we don't want to placard every single building in the city, was if it doesn't have a placard, you'll pump that building at 150 psi. If it has a placard, you'll pump whatever's labeled, and then the only buildings labeled are above 150. And that's how the city chose to do it when we did that project. Is there any more questions before we go?
No, sir, that was it. Thank you.
All right. So as we're talking about FDCs, right, we talked about when we're going to hook up to them. We always hook up to it, but when we're going to put water into it and things like that. But you can run into some problems at the FDC. Some are easily fixed. Some there's nothing we can do about, and we have to figure out how we're going to overcome it, whether it's just fixing the problem or having to bypass the FDC and things like that. And we'll show you some video on how to do different things or what you might be able to and might not be able to, and understanding why. So some of them are easy, right? A fixable thing like a stuck cap, frozen swivel. These are things we can fix pretty easy. You get into something like that picture in the background with the whole FDC is missing. The FDC fell off the building. That happened about an hour and a half away from me a couple of years ago. We're near the coast, salt water, and things happen and lack of maintenance. So being prepared for it. But you could also just have one of those, and I'll show you a video of it, of one of the FTC Siamese inlets is dented, right? It didn't have, most of ours, we have the Knox cap in it now to keep people from stuffing stuff in it and messing with it. But this was, and how we found it was it stood out. You're driving past it and you're like, man, it's got one Knox cap in it. And the other side doesn't have a Knox cap. I wonder why. Let's get out and look. And it's because somebody messed with it and they actually dented that swivel. So it's not round anymore. You're not going to be able to hook up to that inlet, right? But we got to know, can we fix it, or is it completely out of service? So we got to know how to kind of look at these things, right? So a stuck cap, get that cap off. Frozen swivel. There's a few things we can do for a frozen swivel. So for us, we prefer to just twist the hose because there's no trips back to the truck for appliances. Twist the hose 5 to 7 times to the left, put it in the inlet and tighten it up. Okay. Now you got your hose in, the swivel didn't work. It didn't really matter. So 5 to 7 turns to the left, put it in the outlet and turn it. You could use a double male followed by a double female. All you're doing is recreating that female swivel, but with one of yours that works, and then hook your hose up to it. Again, we prefer the twisting the hose because it doesn't involve that trip back to the rig to get that equipment. Okay. Or you could use a Siamese and just twist the Siamese on there and hook your hoses up there. Again, you're going back to the rig. If you have a hydrant kit on your rig that you carry and it's got adapters in it, if you're going to hook up to the FTC, bring it with you, right? Use that hydrant kit that might have some of the equipment you might need. If you're the driver hooking up here, bring that with you and maybe you have the answer to a problem you could have. But something like a frozen swivel, for us, just twist the hose 5 to 7 times to the left, put it in the inlet, tighten it up, and you're good to go. Okay, but now you get that dented swivel. So you're looking at it. You can see it's not round. There is no hooking up to that side of that inlet, right? But depending on if there's a clapper valve in place, we can still use this FTC. Now, if there's no clapper valve, the clapper valve is behind the wall or is broke, whatever it is, and water is just going to flow from the other side. If you put water in and come right out this side, you're going to have to bypass this. But if the clapper valve is in place like it is here, just use the other side of this FTC, and it doesn't really matter to you that this is messed up and not working, right? So as we look at it, it's at around. We would just put a Siamese on the other side and run both supply lines into that side of the FTC. That's how we overcome it, right? So maybe it's something you don't think of all the time, but these are things they're not hard to overcome. But if you're not training on them or talking about them at 3 o'clock in the morning, it might be something that's hard to overcome, right? Give your guys the opportunity. Don't expect them to just know it, especially if they're new. Oh, the training academy would have taught them. Make sure you teach them. Don't expect them to know something you didn't show them yourself. Something simple like that. It's a good drill for young guys. Go out and then you learn your buildings, right? 3 o'clock in the morning, they pull up. They already know this building. This is what they got to do because they put their hands on it. They'll remember that. Okay. So if the FTC fails, it's completely out of service. It fell off the building, whatever. You have that dented inlet, but there's no clapper valve. We have to bypass the FTC for whatever reason. We're bypassing the FTC, right? Everybody's probably heard the easy solution is stretch a line to the first floor outlet and supply the standpipe outlet on the first floor to charge the standpipe riser with water. And that does work as long as it's a standard valve. If it's a PRV, you can't do that. PRVs are essentially one-way check valves. Water can only flow one way, okay? So it's not going to allow you to backfill the system through the outlet if it's a pressure-reducing valve. It would have to be a standard valve. So if you go to the first floor and you see an outlet like you're seeing right now before I start the video just on a still screen, you're good. That standard outlet, you can charge this system by going with a line to the first floor standpipe outlet. But if it was a pressure reducing valve like you'll see in this video, and you'll see how it's not going to work, right? So you got to be able to look at your building, go, okay, we're good, or get on the radio and say, hey, it's a pressure reducing valve on the first floor. It's not going to work. We've got to come up with something else, right? So you got the standard outlet. So we've got the line charge going into it. It's charging that's filling that riser with water so we can operate from it on an upper floor, right? So it worked perfect. We charge the riser on the first floor. On the upper floor, we have water. But now we have a pressure reducing valve. So we're in the exact same setup. But when we get up to the floor above, on this, just one floor above, but wherever in the building, you're going to see no water's getting in the system. And we'll talk about it at the end of why. But if you notice, as we're spinning that hand wheel, the plunger inside that outlet is not moving, right? Hand wheel's all the way open. But as we look in there, it stayed seated, right? It's still seated at the base of that opening of the standpipe outlet, right? It's not allowing water in, okay? But the one on the first floor did the same thing. When you open the hand wheel, it stayed seated. So water's sitting on top of that plunger, essentially forcing it closed even more versus allowing it to get into the riser to fill up the system. Okay, this isn't a threaded stem, which I'll show you later, like a regular standard valve, to where when you spin the hand wheel, the plunger opens up, right? It rises and it allows that whole opening to be open, allow water to go either way. With the PRV, it's seated, right? The plunger's seated. As you trying to open the hand wheel, right? It's allowing room for water to push the plunger open, coming from the riser, not the other way. It stays seated like you're seeing right there. So it's not going to allow you to do that. Okay. So if you get to that first floor and this is the route we're going, FTC has failed, we've got to bypass it. We're going to charge the first floor standpipe outlet to backfill the riser. You see one of these pressure reducing valves, and by the end, we'll go through every single one of them. You'll be able to recognize them. Get on the radio. This isn't going to work, right? We can't backfill these. They are essentially one-way check valves. Okay. So you get to elevators. So one, we only use them if we can take control of them, right? We have to be able to take key control of the elevator. We want to make sure it's only going to go where we want it to, and we don't want to get stuck, everything like that. So if you can take key control of it, elevators are an option. Okay. Before you get in, look up in that elevator shaft with a flashlight or things like that. Look for signs of smoke, fire, things like that, right? There's a shunt trip in there. If that shunt trip goes off because water, heat, anything activated that shunt trip, the elevator is no longer going to rise and fall for you. It's going to shut the shunt trip down. You're not going where you want it to, and you might be stuck in the elevator. So for us, 7 floors and above, we can use the elevator. From the 6th floor down, we walk. That's written in our SOGs. It's just a timing thing. If you're going to get out 2 floors below anyway, on the 6th floor, that'd be getting out on the 4th floor. By the time you take control of the elevators and everything like that, we could have already walked up there. So that's why that is for us. It's a timing thing. We stop 2 floors below. One, it's a safety, not end up, stopping on the wrong floor, but also going back to stairs, right? As long as we get out 2 floors below, we get in a stairwell on the side of the building we want to be. It doesn't matter now. Sorry. Return or scissor stairs. We're going to be where we want to be. Orientation's correct. Okay. Always bring your forcible entry tools with you. And then if you can, assign an elevator control firefighter that's just going to operate the elevator. Their job's going to be to bring people up and down and assign them, get them where they got to go, and keep track of everything. I know that's hard to do if you don't have a lot of people. For us, it's a second alarm assignment. It's not an initial assignment. Guys are just happen to do it. But I also show you this for a reason. Not all those keys are the same when you have to get an elevator. So if you're not carrying elevator keys for your area and your city doesn't require all elevators to use the same elevator key or just one of 2, there's like 29 or 30 options that key can be. So we went and studied all the elevators in our first due area, and that's my personal set of keys for them, because we got sick of going to the front desk saying, hey, we need elevator keys, and relying on them to know where they are and have them available for us. Okay. Or they only had one. And if I took the elevator up and didn't send it back down, everyone else was walking. So we got elevator keys for our engine ourselves. And then the department ended up following suit and doing it for every engine and every truck. But we went and studied all the elevators in our run area. And just in my first due, which is 3 square miles, it's not very big, and 1 square mile of it's the bay. So 2 square miles of buildings. There's 10 different elevator keys in my first due. So if you're not mandating it's only one and you go out and get an elevator key, don't necessarily think it's what's going to work. Kind of get out and know your buildings. Or hopefully your city's not doing what we're doing and they're dictating it can only be one of 2 or 2 or 3, so that you're not having to go through as many keys trying to find it. Okay. So now we get the hose line. We're getting ready to put the hose line in place. We need to staff it. Okay. We're going to get into the hose of what sizes to use and how that plays out. But understand you should be using a bigger size hose line here. Maybe in residential, you're in that 2-inch. I'm a fan of it. It's not what we use. I was a fan of the blended idea. It's not what passed the committee. The Chiefs didn't want that. They wanted everything in one size. So we went with 2 1/4, but you're going to be in a bigger hose, especially if you're dealing with commercials. So staff it correctly, right? If you just put one, we got 3-man engines. We're going to put, 2 people on this line. You're not going to get where you got to go. So staff it correctly. It's better to marry your companies together and put multiple companies on one line and have that line be successful than have multiple companies trying to get multiple lines in place and have none of them be successful. Most fires are going to get put out by one line, right? You're stretching that second line and backing them up, things like that, but it's going to get put out by the one most of the time. So staff it correctly. Commit your people to where they'll be successful. So to me, the biggest thing was the staffing you pull up with on your rig doesn't determine what hose line you pull, right? It doesn't say, well, we only ride 3, so we have to use 1 3/4 on standpipes. And this goes to every fire, but on standpipe, right? That's what we're talking about. It doesn't mean we got to use 1 3/4 because we don't have a lot of staffing. We're not going by ourselves. We're not the only engine going. Put multiple companies on that line and let the hose line determine the staffing you put on it. Okay, standpipe operations are very pressure sensitive. There's only so much pressure available. So we're in bigger hose. Okay, cool. We've reduced the friction loss that way. We're making sure we get the flow we want through the system. But now we have to staff that bigger hose correctly so we can actually be effective with it. So what we do, our optimal is 5 to 6 people on the line. Okay, that's not including the person down on the street at the pump panel. That's 5 to 6 people from the outlet to the nozzle. All right, and then the 7th position is that pump operator. And we buy SOG. If we hook up to a standpipe, we automatically put 2 engines in a truck together. There's always 2 engines on every line. What that does is it gives us the people we want. It gives us 5 to 6 people, but it also gives us, because everyone carries all their stuff up. So it gives us 6 lengths of hose and 2 fully equipped standpipe bags. So those are the benefits we get by marrying our companies. But this way we can put that bigger line in place and be effective with it. All right. So I had shown that slide in a class one time, and it got shared on Facebook, and there was some people that didn't agree with it on Facebook, that they don't have the staffing to put, a lot of people on the line, weren't really thinking and understanding it was out of a standpipe class, and what you're dealing with, that you don't really have a choice sometimes of that you have to use bigger lines for what you're dealing with, because it's pressure driven and things like that. But when it started, all the Facebook conversation started, Chief Dunn, everyone probably knows him from FDNY, a legend, right? He reaches out to me. He's like, here's my picture. This is how you should commit your people on this. And it fell to right what we did. Where a lot of stuff's modeled after them with this stuff. They got a lot of people, but you could still staff your line this way so that you are successful and you're putting people in place to be successful. Just put your companies together. But one thing I want everyone to notice in this picture is everyone's gear looks the same except one person, right? They put a white helmet on one person. That's the company officer, right? A lot of times because of staffing nowadays, right, that company officer isn't necessarily just supervising anymore like design, right? The design is they're up there, they're supervising the nozzle crew if you're an engine boss. And that's not the reality of a lot of house fires. You're having to help them pull slack because it might just be the 2 of you and things like that. But how many times are you going to high-rise buildings fires and operating off standpipe systems and things like this? You want that experience. You want that company officer up there actually supervising. And by staffing your line like this, by marrying companies, not only are you giving the people to make the line successful, you're making sure that line's actually being supervised. So, because you're not doing these fires all the time. All right. So as we get through to it and we start looking at how we get to the decision-making of the equipment we're using. Okay. So we go back to NFPA 1710, which is that staffing standard, right? It also dictates how much water we flow for different fires, so we use 1 3/4 hose, and everyone says the national standard minimum flow rate is 150. And that comes because this standard says in a house fire, the first 2 lines will flow a combined 300 gallons per minute. Neither one will flow less than 100 gallons per minute. And simple math just says 150. Okay. So it does the same thing here. It's telling you in the standard, the first 2 lines on the fire floor will combine to flow a combined 500 gallons per minute. Okay. So that's how we're coming up to our minimum flow rate is 250 gallons per minute. Okay. That's where that comes from. So I'm just going to click through this. Usually we have a lot of interaction about this slide, but it's kind of hard to do that with a computer. So if you know which fire that is, you're going to see where we're going with this. But that's the One Meridian Plaza fire, right? This fire really changed a lot for the American Fire Service when it comes to standpipe operations, based on pressure reducing valves, recognizing a lot of the fire service is using 1 3/4 hose or fog nozzles and things like this. And this was in 1991, right? This happened in 1991. I worked for a pretty decent sized fire department, 500 guys, things like that. 3 years ago, we finally made the change from doing the same kind of thing they were doing here, except we had companies using fog nozzles. They just weren't automatics. They were fixed. That was the difference, right? Our downtown crews weren't. They weren't 2.5. They kind of learned, but the companies that didn't deal with high rises a lot, they weren't set up for that. But what they didn't realize is if we have a high rise fire, everyone was coming down. So we need to get everybody on the same page. And there's still a lot of people using hose. That's not necessarily what the standard's designed for. So with One Meridian, if you're not familiar with it, 38-story building, heavy fire on the 22nd on arrival. Okay. It ended up extending up until it reached a sprinklered floor, and that put it out. They had a ton of building problems like loss of power, everything. They actually had to evacuate the building. They were worried the building would fall down, all sorts of things, right? And a lot of their problems came from they had an improperly set pressure reducing valve. They're using 1 3/4 hose lines and automatic nozzles. Okay, so they could not generate a fire flow adequate for much of anything with that. And ultimately, it led to 3 line of duty deaths, right? So this was the wake up call for the American Fire Service. So if you look at that NFPA 14 standard, right, we always say 1993, pre 93 and post 93. That was the next update to the standard after this fire. And that change was driven by this fire. Okay. So what we have to understand with that standard is it's written. If you read the whole standard, it is written and it says in there it's designed based around a hose nozzle package of 3 lengths of 2.5-inch hose with an 1 1/8 smoothbore tip. And that's where they come up with the pressures. But they did make some changes after this fire because what they recognize, Philadelphia is a pretty big city, right? It's one of the biggest cities in the country. So if they're still using 1 3/4 at this time with a fog nozzle, a lot of other people are too. And we need to increase some pressures because that not everyone's doing the way this standard was written. Okay, so when you're going to do your hose, you're figuring out what to do. This was us, and I'm going to show you our actual results from our study. There's a few things you had to evaluate. Are you running in pre-93 or post-93 systems? Again, remember, what year did your city adopt that standard? Like for me, it's not 1993. We adopted it afterwards. So most of my buildings are post or pre-93. We're an old city. We have very few buildings that are in the post standard. So we're in that lower pressure standard. Okay. Then are you dealing with commercial or residential? Because what does your fire flow need? Okay. We have a lot of commercial high rises that factored into our decisions. And then what are your options? You have 2.5, you have 2 1/4, you have 2-inch, you have the blended. You have to figure out what works for you. Like I said, I really like the blended. It wasn't something our chiefs wanted. They wanted if we hooked up to a standpipe, it was all the same hose, same size, the whole deal. So that's what the committee was set out to choose from. And the option the committee chose with that was 2 1/4, which I am a fan of. It doesn't fold good. That's the only kind of thing with it, but it operates good. So this is what we found. So we did the same 3 things for every single test, right? So we did 1 3/4 hose. We ran different nozzles, right? We ran the 7/8. We ran the 15/16. We ran a 150 at 75, the department was using at the time. And then we ran an auto, even though the department wasn't using autos. There was a few sitting on reserve trucks. So we put that through the test too. And every line was tested at 100 PSI at the outlet, 65 PSI at the outlet, and 40 PSI at the outlet. So the post-93 standard, the pre-93 standard, and a worst case scenario, One Meridian Plaza type scenario. Okay. And that red line on the right, that's that national standard from NFPA of how much we need to flow for that fire flow. Okay. So you can see nothing in that 1 3/4 came close. And all of this was with 3 lengths of hose, 150 feet. Okay. So then we get here. You can see with the post 93 standard, right? We were able to exceed that 250. The 1-inch wasn't coming close for our chiefs on the pre-93, which is our world, and nowhere near on the 40. And then the 1 16 was a little bit closer on the pre-93, which is, like I said, where our decisions were made. That's most of our buildings. But this wasn't really what the chiefs were looking for us. So we moved over. Here you see numbers again, pretty similar, right? This is where we ended up. Okay, so 1 1/8 is what we use. We were able to far exceed based on the pre or the post 93 and the pre 93. Wait, oh, I can't see the screen. I might have skipped past it. We might be on 2.5 now. We on 2.5 now? It's blocked on the top of my screen from the chat thing.
Yes, sir. Yep, on 2.5.
Okay, I got ahead of myself. But so you can see why it's the standard, right? Pretty much no matter what, you can reach that standard. Okay. So here's where we are. We're in the 1.1/8. I got ahead of myself on the screen because I can't see the top of my screen with the chat thing. We're in the 1.1/8 right here. Their goal was to be as close to 250 as possible in the pre-93 setting. They didn't really want to go all 2.5. They felt they made a decision based on what they felt members would go for. And they didn't think people wanted 2.5. So this was kind of the winner. And they also had a kind of a number they wanted to be near in a worst case scenario of 40 PSI. Even though it's flowing good water there, 170 is not bad water. The hose is not performing well. It's got kinks and it's pissing water. It's not, you don't have a stream at 170. It's just pissing it out of the nozzle. You don't have an effective stream. But our goal was at 65 PSI, what we should be able to expect from the system. We were as close to 250 as we could is what the Chiefs wanted. And this is what they settled on. And then this is your gold standard. Okay. But then you also get nozzles, right? This is I like smoothbores. We use smoothbore nozzles on my engine for everything except car fires, really. But I'm not the guy, like if you're making a house fire and you like 5 nozzles, that's a personal preference to me. Here, it's a different story. When you're hooked up to that standpipe, there's no reason to use anything but a smoothbore. And you can see it in the video on the bottom and the picture on the top right. The stuff that's going to come out of these outlets, right? So the picture on the top right, that's from the helmet cam in a fire in Houston. That's what came out of that outlet. The picture on the right is the video on the bottom right is Jared Sergi from Norfolk, Virginia. They were doing a building inspection and they allowed the guys to be a part of it and flow a line as they did their flow test of the system. That is the stream that came out of that standpipe. Don't expect this to just be normal, clear water. A lot of stuff is, water's just sitting in that pipe for a long time. You're going to get sediment coming through it. Have a nozzle that looks like that view on the bottom left. If it gets in the nozzle, it can pass out of it. There's nothing in the way to let that debris just clog up your nozzle. You can flush, it just flushes itself out. It comes out the front of the nozzle. So being that smoothbore here, it's not like your house fires. It's not the personal preference anymore. This is what the standard's written around. So use it here. It's not that personal preference. That's the big point. Everywhere else, it's kind of personal preference. Here, it's not. Use that smoothbore nozzle. Okay, so as we get into the valves, and we're going to spend some time on this because I want everyone to be able to look at a valve if you see it, know what you're up against, and then if it is a pressure reducing valve and it's not giving you enough pressure, know if you can actually do something and adjust it. Because that's what happened in One Meridian Plaza. That valve was adjustable. The American Fire Service hadn't been trained on how to adjust it. Okay, so it could have been adjusted to give more pressure. The American Fire Service just didn't know how to do that yet. And it's been a big thing since to make sure people do. So this is what everyone's probably the most comfortable with, the standard valve. It's probably in most of your training building. It's the cheapest. Okay. In an older system, it's less than 100 pounds. In a newer system, it's less than 175. Okay. But the biggest thing to know here, there's no pressure restriction or reduction. Okay. There's no pressure restricting device on it. There's no pressure reducing valve. What pressure's there is yours. And what comes with that also is if you start pumping the system and you say we need more pressure, right? When your driver gives you more pressure, minus the head pressure, you get it. Okay. If they gave you, head pressure plus 10 PSI, you're getting 10 PSI minus the friction loss in the valve. But if you had a pressure reducing valve and it was reducing it by 50%, that 10 PSI to the outlet, you only got 5 of. It's going to continue to do its job. So here, you're going to have nothing cutting back that pressure for you. Okay. And here's where we're going to hit that NFPA because this is the part people focus on. We don't necessarily always focus on the whole thing. So again, I'm driving it home. Remember, don't always go by 1993. That's when the standard was rewritten. Go by when your city adopted it. That's when your city changed. Okay. And everyone focuses on this top number, right? This top line, the minimum outlet pressure. It was changed. It was 65 PSI was the minimum outlet pressure, and we increased it to 100. But look over there underneath where it says minimum outlet pressure. We have to recognize that part. It's a minimum outlet pressure of 65 PSI with 500 gallons per minute flowing. Okay. So if you hook up, you're the first line, you're the first outlet getting hooked up to, And when you charge the system and you open the nozzle, you're already at 65. That's a warning. Okay. This is a light bulb moment because it's not supposed to get that low unless you were flowing 2 outlets, right? 500 gallons per minute, not 1 outlet. So if you're only flowing 1 and it's at 65, you're already not operating the way the system's designed to. So we have a light bulb moment here. Okay. But we focus on the minimum. We need to recognize with One Meridian Plaza, the minimum isn't what caused the issue there. Okay. Because it had a pressure reducing valve, which means there was more than 175 pounds of pressure at that point in the riser where that outlet was located. Right. So they had 175 pounds of pressure, but because it was over 175, a pressure reducing valve was required to be there, and human error came into play. It was improperly set and installed. Okay. So human error, but the human error was allowed not because that minimum, but because the maximum. This standard also has a maximum outlet pressure it allows. Okay. Engineering in safeties for us. Remember, the standard is written around 3 lengths of 2.5 inch hose with an 1.125 smoothbore tip, right? 65 pounds of pressure is what you need. Okay. So they tried to engineer in safety. We don't want to have these lines just be extremely overpressurized and unsafe for the firefighters that are going to use it. So they engineered in some safety. We weren't necessarily always using what that standard was written for, but also adding that valve added in the possibility to allow human error. Okay. So again, it's with 500 gallons per minute flowing, but in the pre-93 setting, 100 pounds is the most that outlet's ever allowed to put out for your line. In the post-93, it's 175 pounds. Okay. So I operate, like I said, the pre-93. So I have 3 different types of things I can run into. If I have a standard outlet valve, I know I'm between 65 and 100 PSI. If I have a pressure restricting device, which I'll show you in a minute, I'm between 100 and 175 pounds of pressure at the outlet. Okay. And if I have a pressure reducing valve, I'm over 175. Okay. So pressure restricting device to me is a good thing because we remove them every time. We always remove it. But our line, perfectly optimal charged, is 80 pounds, is what we set it to. So if I remove that outlet, I now know I have over 100. We're going to be gating it back. We have more than we need. We know we're good, right? But now you're in that post 93. So they increased the minimum. They increased the maximum. They eliminated the pressure restricting device unless your city just writes it into your building code, your fire code. Okay. So now your standard angle valve is 100 to 175 PSI, and your pressure reducing valves are over 175 PSI. Okay. So this is what you're looking at. The top 4 is pressure restricting devices. The bottom 4 are pressure reducing valves. Okay. So terminology to me helps you understand these and identify them. So pressure restricting device. So it's an external device added to a standard outlet, and it's going to restrict the way that outlet operates. Okay. A pressure reducing valve is going to internally reduce the pressure in the valve. Okay. Does that make sense to everybody? And we'll move on and go through each one individually, how to beat them, how to address them. But does that make sense to everybody how they work? All right. So talking PRDs, right? Pressure restricting device. So if you look at the top 4, they're all just external devices added to that standard valve. And there's one of 2 ways it's going to act on that valve to restrict the way that it operates. The 2 on the left, top left. Okay. One's an orifice plate. It's in a cap there instead of on the outlet. You'll see how it works in a minute in a video. But all it is a brass disc, right? So you have a 2.5 inch outlet. Okay. So there's your standpipe outlet, but it's got too much pressure. So we're going to take this 2.5 inch outlet and we're going to insert and press into it a brass disc that is only going to allow now 1.5 inch outlet. Okay. So that we can restrict that water flow through the outlet. The second one from the left is a mechanical adjustable device. This is what you find in the New York City stuff. It operates on the same principle, except instead of having one disc for each outlet that has to go in a specific spot, they can adjust this. So those fins you see inside of it, they can adjust it. Okay. And they use the fins to restrict down the amount of the orifice that's open. And then they just thread this on the outlet, and then you're restricting your pressure. So all we got to do is remove it. Okay. Then the 2 on the right, they're going to operate in a different way. So the first 2, they restricted the size of the orifice down. The second 2 are going to restrict how far the hand wheel can open. Okay. So the third one from the left, it's just a stem. All it is a stem with a stop. So as you're opening at the hand wheel, you're threading it, right? It's opening. That stem hits the stop. It doesn't let the hand wheel open anymore. You remove the stem, hand wheel opens all the way, right? The pin works the same way. All it is a pin with a stop. So as you open the hand wheel, the pin hits the stop. It doesn't allow the hand wheel to open anymore. You pull the pin out, hand wheel opens all the way, right? All of these are removable. The orifice disc, rip it out of the outlet, get it out of there. You now have every bit of pressure. You have a standard valve again. The mechanical adjustable, unthread it from the outlet threads and hook your equipment up directly to the outlet. You've defeated it. Every bit of pressure there is yours. It's a standard outlet. The stem, remove the stem or break the stem. Your choice. And now all the pressure is yours. Remove the pin. Okay, with the stem, this style right here you see in the picture, if you look close, you see a knob on the bottom and a notch right above the knob, right? It's a breakaway knob, so you could, instead of removing the stem, you could just break the knob off and that'll allow the hand wheel to open. Okay, so you can use the forks of the Halligan or that notch and twist the Halligan to break the knob off. That's a lot easier said than done though. Credit to the guys up in Toronto and their high-rise unit, Brent Brooks and them. They did some ways to figure out how to do this easier. If you carry a pipe wrench in your standpipe bag, use the pipe wrench on the hand wheel like a cheater bar and just crank it open and that knob will break off the bottom easier than trying to twist it off with the force of the Halligan. So just options there. Okay, so then we move down to pressure reducing valves at the bottom. So the bottom left picture, that's the concern. Okay, there's nothing in there we can do. If it is wrong, it is wrong. That is a factory preset pressure reducing valve. The other three on the bottom, all it is a giant spring. Okay, so we can take action to adjust the spring to allow ourselves to get more pressure if needed. The one on the left, there's no spring, it's all metal. If it's installed in the wrong spot, again, it's going to do what it's designed to do. So how does it become an issue? Human error, right? We allow it gets installed in the wrong spot, human error. So if it's installed wrong, if it's in the wrong spot in the building, okay, there's nothing we can do to fix it. This valve's not going to give you enough pressure. Go to plan B. So for us, anytime we see one of these valves, everyone already knows we're on plan B. If this valve doesn't give us enough pressure, we're going to add another length of hose, drop one more floor below, and hook up to that one. That's kind of plan B, and we work from there. Okay, but there's nothing we can do to adjust this. We're going to go through step by step in detail these other three, how to beat it. Okay, so as we go through it, usually this is a little discussion, but we'll just talk about it. Typically, if I was to say, which one of these pictures, the one on the left or the one on the right, would you expect to find pressure restricting devices and PRVs, right? Everyone's going to say the same thing. It's pressure driven. It's all about pressure. So which building is going to have higher pressure? The tall ones. The pictures on the left is where I expect to find these, okay? And that is 100% right. They're in those buildings. They're also in this 3-story assisted living 3 blocks from my firehouse. The building's overpumped, okay? It doesn't need it. It shouldn't be designed in. It shouldn't need pressure restricting devices or anything in this building. But the fire pump overpressurizes the system in this building, puts it over the limits of that standard, and now those are in this building as well. So they may pop up in places you don't expect. Get out in your buildings. I said, you make a medical run, take the elevator up, deal with the medical run, take the stairs down. It's not, especially if it's on a lower floor, check out what valves you got. Are they in the stairwell, on the hallway? Talk about them with the guys. It's easy training, nice, informal, laid back, and people can remember those things and get a lot out of it. Okay, so here's those pressure restricting devices we talked about. Okay, all they do is limit how that standard valve works, right? Limit the size of the orifice, limit how far the hand wheel opens. Okay, they also only reduce pressure when water is flowing, not static, just residual. Okay, so this is each one being removed. So it's obviously not pressed in, but if it was pressed, that's what you want to do. You want to remove the orifice disc. The mechanical adjustable, you're just going to unthread it. Take it off of the outlet. All right, here's your pin. So you're going to see the pin rise. It's going to hit that stop. Hand wheel won't open anymore. Release the pressure on it, pull the pin out. Hand wheel opens all the way. And then same thing with the stem. Obviously, these are training valves and they're mine personally, so I'm not going to break the stem off. I'll show you how to remove it. You just use the Allen key, you drop the 2 screws out and the stem falls out. Right? In real life, reality driven in this, we would break the stem on our job. Just being a training valve, we just pulled the stem out. Okay. But the way we operate, if we run into a pressure restricting device, any of these 4, it doesn't matter. We remove the pressure restricting device every single time. Pin or stem, it doesn't matter. We don't wait until, oh, it didn't open enough and we needed more pressure. Let's break the stem off or pull the pin and open it. We eliminate it from the start. As you're hooking the equipment up, whether it's an orifice disc, a mechanical adjustable, a pin or a stem, it gets removed, right? Because an orifice disc or mechanical, if you hooked up and found out you needed more pressure, you'd have to shut it down, disconnect your equipment, remove it, and then start the process over. We don't want guys thinking, you know, oh, this is one we do remove to start. This is one we wait and see if we need. We just remove them all to start with. We can gate it back with a gate valve. Not a big deal to us. Okay. Here's your factory preset. Like I said, if you look at that cutaway, there's nothing to adjust there for this pressure reducing valve. It is what it is. If it's wrong, it's in the wrong spot, you might be screwed. Maybe it's enough for what you need. Maybe it's not. But if it's not, there's nothing you can do to fix it. Okay. Everything else is a stem. As you look in that picture, there's no, or a spring. There's nothing in that picture that's a spring. The builders or the building owners can buy whichever pressure reducing valve they want. They just have to put a pressure reducing valve at that point in the system. Okay. So this one's cheaper than the adjustable ones. So they may just go with this. I'm seeing renovations in my city, in my run area, where they're redoing systems. They're removing factory or field adjustable valves that we can adjust and putting these in there that we can't take action on. It's not a good move. The city's trying to do some wording in the standard to stop that from happening. But now those buildings for a very long time are going to have this when they had outlets that we could adjust if we needed. All right. So not all of them. If you look, you see this big bonnet at the base of the hand wheel. The Zern doesn't have that big bonnet on it like this. But if you remember that, it is bigger than a standard outlet, even though it looks pretty similar. But if you see that big bonnet, we just always tell our guys, big bonnet, big problems. Be expecting that. As soon as you see it, expect you could possibly have some problems. Okay. But here's your field adjustables. Okay. There's a couple more out there now. Really just one. There's one more out there now. And I'll explain it later. I don't have a video of it. I do have one, and I don't have it on a prop, but it's identical in operation for us to the IRFA valve, which is the 2 pictures on the right. It's made by Zern, which is the top picture on the left. And it mimics that one on the right very closely. But for our operations, it's pretty much identical. So when we go through the video of how to do this valve, you'll understand that Zern valve as well. So again, anywhere there's over 175 pounds of pressure at that point in the system, you're going to have one of these. Okay. It's going to be set at installation. Understand, set at installation isn't the way, at least I always thought of it, right? I'm thinking, okay, so its pressure is set at installation, meaning they put it on the pipe of the riser, they float it, and they set the pressure to be where it's supposed to be. Not the way it's done. It's still set in a vise at the factory. Okay. For designed to go in a specific spot in that building, just like the factory preset, set in the vise and labeled where to go, and then it gets installed. And that's considered set at installation. Okay. But it can be adjusted in the field. Okay. So here's where this is different from this. So when we go back to this, okay, so this is where I saw one. The actual body of the valve was labeled. It was engraved and it said 3. Okay. So if you think about that, on the 3rd floor where there's the most amount of pressure, the stem we'll say the plunger can rise this far in the opening. On the 3rd floor where there's the most pressure, it's only going to rise like this, right? It doesn't open very much to keep that pressure low. But even though it was labeled 3, it was installed on 30. Well, on 30, it needs to open the whole way. And there's nothing you can do to adjust it, right? But with these, we can take action on that spring so that even though it's only opening here because it was designed to be somewhere else, now we can take action on the spring and allow it to rise all the way. Okay. So the first one, this is the Giacomini valve. This is the One Meridian Plaza valve. This is the one they ran into. It's the simplest to adjust in theory of what you have to do, but it's the oldest technology. So it requires a lot of force. Okay. To adjust this valve, you're going to insert a 3/8 inch steel rod, a cold rolled steel rod. If it's an aluminum rod that for some of the other valves, it's just going to snap off, bend and snap. It's not going to do anything for this valve. Okay. It's going to go in that hole you see right there on the collar, right between where it says open and close, or right below where it says open and closed. Okay. And you're going to turn it. All of these valves are the same. We turn them clockwise to increase pressure, right? It sounds counterproductive to the way we think, right? Because everything we do is righty tighty, lefty loosey. But you've got to think about the spring. There's a spring in there. And what I want to do is I want to make more room. So I need to tighten the spring. Okay. So just keep it in that mind. You'll always remember we go clockwise for more pressure. And remember, we're never going the other way. Use the hand wheel or a gate valve to reduce pressure. Don't take action on the valve itself to reduce pressure. We only act on the valve if it's not giving us enough and we have to do something to get more pressure. Okay, so we put that 3/8 inch steel rod in the adjustment hole. We're going to turn the rod clockwise to get more pressure. Counterclockwise would be less pressure, but we're not going to do it that way. We'll do it with the hand wheel or the gate valve. Okay. Now keep in mind, turning that rod, this is a training prop, gets used a lot. Turning that rod takes 75 pounds of force. And that's from the factory by design. So by design, 75 pounds of force. Now you factor in, it's been in the building with water in it for 10 years. It's probably not going to move. Even if it does, you just saw you're not gaining a lot of pressure very quick. This is going to take some time if you have to change pressures a good bit. We'll probably go over about 10 minutes, just getting through everything. Then you have the ERFA valve. So this is the same concept, okay, but a much, much newer technology. So instead of 75 pounds of force to turn that adjustment collar, it's only taken about 12. So they had to add in this plastic shield you see, that's an anti-tamper shield, so no one can mess with the valve. Basically, if you have anything in your pockets that'll fit in that hole, you'll adjust this valve, okay? So now we have to deal with the anti-tamper shield because we got to get it out of the way so we can adjust the valve. That anti-tamper shield is not normal plastic, it's Lexan. It is not easy to break, okay? It's got a small set screw. You can if you have the right Allen key, you can pull the set screw out and life's easy. You just lift the collar up, you adjust the valve. If not, you're going to have to break it. Break it in that adjustment slot that you see in that picture on the right and pick the top. It's the smallest piece of Lexan. Once you break it, you can pull it apart, but you do have to break it, okay? And then it follows the same thing. You get rid of the anti-tamper device, which is a T25 anti-tamper torque key. A regular Allen key is not going to work. It's got to be an anti-tamper key that's got the little nipple in it. Otherwise, it doesn't fit because that set screw's got that nipple, all right? Then everything follows the same. Lift that collar up, put the 3/8 rod in the hole, adjust it by turning it clockwise. Here, it does not have to be that cold rolled steel rod. Aluminum rods work perfect, okay? It's what they're designed for. Like I said, I've used the same Allen key that I took the Allen screw out to adjust the valve before. It wasn't easy, but it will adjust it. It doesn't take a lot of force. But again, you'll see just by, going by the quarter turns of the rod, you're not going to get a ton of pressure change. But the fact is, it's very easy to do. You can outrun your gauge very easily because it's so easy to turn the rod. So what we try to teach our guys is a quarter turn, glance at the gauge, quarter turn, glance at the gauge. And what that's doing is giving the gauge a second to react so you don't go up too much and then you're trying to come back down and back and forth. All right. The newer model of the Zern is almost identical to that, but our action is identical. The only difference for us is there's 2 set screws and the shield lowers instead of raises. But put the rod in the hole, turn it clockwise, it's very easy to turn. The older model Zern here, to me, is the most difficult for people just because you have to take the valve apart. Okay. So when you're looking at it with this cutaway, right above where that cutaway stops and you see the red spring, that nut right there that's holding the hand wheel assembly on, you're going to have to remove it to adjust this valve. Okay. The whole hand wheel assembly's got to come off. Okay. And I see everyone back away. They start taking off, they back away like the hand wheel's going to just shoot off under pressure. It's not. It will fall off and break your foot before it shoots off and hits you in the face. Unless you try to take it off with the hand wheel in the closed position. then it's going to hit you in the face. But you probably deserved it because you didn't even charge the line yet, and you're trying to take the valve apart with the piece that you need to, charge the line. So you charge the line, you see you don't have enough pressure. Now you got to take the hand wheel assembly off. So you take an 18-inch pipe wrench and you take that nut loose, and that whole hand wheel assembly comes off. Now you're looking down in the top of this valve, and there's the top of the spring with the adjustment nut sitting on top of it. Use a 1/16 deep well socket, and you can adjust that adjustment nut. Okay. So this is how you go through it. All right, hand wheel comes off. You can see the top of the stem there, and right at the base of it is that adjustment nut. You use your 1 1/16 deep well socket, clockwise adjustments. It can be kind of stiff, but you get a good amount of reaction as you adjust this valve. So again, you can outrun your gauge, okay? If you're not sure what you're looking at, take the cap off and look inside the valve. If it's a threaded stem, like we talked about earlier, it's a standard valve. If it's a smooth stem, usually a fatter as well, it's a pressure reducing valve. But if you have to resort to this, be honest with yourself. You took the cap off, you didn't know what you were looking at, you see the threaded stem. Okay, I have a standard valve. Remember, pressure restricting devices are added to standard valves. Look thoroughly at the valve as well and make sure you take those off if there's any there. Okay, so if you get into a building that has a combination sprinkler standpipe system and you're on a lower floor, it's a big building, and you're saying there should be pressure reducing valves here and there's not, they're there. They're allowed to share the same PRV for both systems. It's going to be in the ceiling space. You may have to pop a ceiling tile and look, but it's up there in the ceiling space. Okay. Carry in your bag what you need. I've got some stuff here. We carry some, we don't, just ideas from different places. So what we carry is the inline pressure gauge, the 2.5-inch gate valve, the elbow with the bleeder valve, all of our PRV adjustment tools, because we don't write our codes to disallow any of them. We have all of them in our city, so we have to be able to adjust all of them. Spanner wrenches, we carry door chalks in our bag. So the concept is, if you have door chalks in your pocket for a house fire or an apartment fire, you should still have them when you get to the apartment door. You shouldn't have to use it to get out of the stairwell. The bag itself should get you out of the stairwell. We carry an increaser because we use 2 1/4 hose, so it's 2.5-inch couplings. If we were to have to extend a line off the tip of the nozzle, we would need that increaser to do so, so we carry it. We carry a choke down tip. We use a 15/16. So if we were in extremely low pressure, again, we're flowing about 170, right? And at 40 PSI at the outlet. But the stream is terrible. It's got no reach. We could at least take the tip off, that 1/8" tip, put the 15/16 on, and create some back pressure in the hose right behind the nozzle. We give up some flow, but we do get some stream back, so we actually have some reach. Okay. Some people carry wire brushes. We don't. Some people carry spare hand wheels. We don't, because of the fact that we don't restrict the valves that are used in the city. The variety of valves is through the roof, and all the different valves, they have different size hand wheels, but more importantly, different size stems that hand wheel has to sit on. So we'd have to carry multiple in order to do that. So we don't carry it. Some people carry an additional nozzle. We don't. The process for us was both engine companies were carrying it up. So there was 2 nozzles. And because we carry the gate valve just for weight purposes, the Chiefs didn't do that. So you're hooking up. The picture on the left is the way we want to hook this equipment up if we can. The gate valve, the elbow, then the gauge. If you're not sure, just always remember the gauge last and everything will work. But I run into what you see on the right a lot. Wall cabinets in a hallway. The outlet is pointed pretty much directly down, and there's not enough room to hook that gate valve up. So then we put the elbow first. It acts as an extension of those threads of the outlet. It gets the threads outside the outlet, so all of our equipment does still fit. But you want to remove the cap, look inside, check for debris. If you have to remove debris, remember, use your tools, not your fingers. Flush the outlet out. Make your hookup. Those are the orders we do it in. Gate, elbow, gauge, whenever possible. We're going to charge the line. We're going to bleed the line. We're going to set the pressure. And you got to remember, when you set the pressure, it's got to be with water flowing. Okay, it's got to be residual. If you set this static, so they're stretching a line, They get ready, they call for water, you charge it, you're at the outlet, and you charge it, and you set it to where you need to be, and they're not flowing water. When they open that nozzle, they're going to lose a considerable percentage of that pressure you set it at. So you got to set it with them flowing water. Okay. The pressure gauge, though, if you don't have any of it and you're fighting to get some, the pressure gauge is the most important, right? It's an easy analogy. I heard Brian Brush say it. We just made the picture. This is your pump panel now. Remember, like for us, we don't even always put water in the system. This is the pump panel. Okay. So we recreate the pump panel. Our equipment, we have a gauge, a way to discharge it, and we have a way to bleed it. But if you were using nothing and no gauge, you're essentially doing that top left picture. You're going to a house fire with no gauges on the pump panel. So the gauge is the most important. We do have a way to bleed the system because our elbow has a bleeder. The stairwell doors are going to open into the stairwell. Your water is going to be running from the stairwell to the hallway. If somehow you, when doing a dry stretch, that door got closed over your hose and the hose got charged, you're not going to get the door open. So you can go down, but without a way to bleed it, you could shut the valve down, but you can't get the water out of it. That door is not opening. Now you can bleed it. You don't have to bleed the whole line, just enough to get the door open, push it flat, get that door open and re-chalk and shut the bleeder down and recharge it, and you're back in the game. Okay. If you're using gated wise, really not a good thing here. We used to, we finally were able to convince the department to ban it. Keep in mind, yes, the standard said 2 lines flowing 500 gallons per minute on the fire floor, but that outlet is only required to flow 250 gallons per minute. Okay. Each outlet's only required to flow 250. The standard has each line required to flow 250. So you're going to have an issue there, and you're constantly going to rob Peter to pay Paul, right? So you're going to have pressure losses and flow losses. So when this line's flowing by itself, it's got just what it needs. But then you see what happened here. And when we did this test, like I said, we had some companies in 2.5, some in 1 3/4. So we did it with both. Look at the amount of water lost from that first line. They're down the hallway flowing water, and that second line opens up. Look at the amount of water you lose. Wasn't a good thing. That didn't win our battle with our chiefs. So we went to the pressure as a safety thing. What is going to happen to the people on the nozzle of one line when the other opens and closes? Okay. So as you look at it, that's 2.5s flowing. Neither of those look like good streams or good hose performance worth the dealing with the 2.5. But do you want to be on that end of the 2.5 when that's what the nozzle pressure is doing, right? It's jumping up above what you even wanted it at because it's getting that surge settling down. But when the other guy opens up, look how far you're dropping. You're going to constantly fall and then get thrown backwards, fall forward, get thrown backwards. So we completely eliminated it. One outlet, one line. Okay. And then you got to be prepared for the unexpected. To me, a lot of these can be expected, right? The problem on the left, it's a real easy fix. It's missing the hand wheel. We just use a pipe wrench. You can operate the hand wheel. Okay. On the right is a little different. Okay. So they use the same valves for the sprinkler system and the standpipe system and put double male nipples into these outlets to make the standpipe system. This building was vacant for about 10 years, and all of this is solid brass. So those removable nipples, when the homeless were living here, all got scrapped. So now this is what we have throughout an 8-story building. It's under construction, so this won't be a problem much longer. But right, so we have no male threads here. So we would say, okay, just put a double male in there. The problem is this end, the end that has to go into that outlet is going to have to be pipe thread. Your standard double male isn't going to work because that valve is pipe thread. Okay. And to finish it up, as we deal with this, we get up there, it's time to stretch. Which hose did we use? How are we going to stretch the whole deal? Commercial versus residential, it makes a difference. There's a few main keys here. In the residential on the right, one, you have a solid ceiling and you have doors. You have the ability for compartmentation and to close this down to just an apartment fire. Okay. On the left in the commercial building, that's not compartmentation. That's just a maze to get lost in, right? It's just more fire load and a way to get lost. It's not compartmentation, but you also have the drop ceiling. Okay. So when we deal with residential, you've got the compartmentalization, the ability to do a dry stretch. If you have a clean hallway, you have door control. If it's a long hallway, you might pop an area of refuge on one of the doors on the way down there in case you have to bail in there if things go south. Okay. Commercial, you don't have the ability of compartmentation to limit this thing's size. Okay. You're going to charge your hose line in the stairwell. You're not going to dry stretch here. We're definitely using a large line. We're going 2.5 inch and an eighth tip, and you're going to open those drop ceilings as soon as you exit the stairwell. You open the door, open the drop ceiling, make sure it's not running above you in that ceiling plenum space. Okay. And I'm just going to give you some examples on how to stretch this. Okay. Both of them, not all the stretches, just 2 quick ones. And that'll be how we finish it up. Okay. So if we do the apartment stretch, we're stretching that line. We've still got the 50-foot nozzle's length on our shoulder. Okay. We get to the door, we lay that down, we flake it out. We got a nozzle and a coupling at the door, 50 feet accounted for the apartment. Flake the line out. We're going to charge the line, and then we're going to bleed it. They're going to set the pressure while we bleed it. It's got to be a long bleed. We're not burping this like we do house fires. Okay. And you want to look for the elevators and bleed it in the other way. Because if you put water in the elevator shaft, you're going to activate that shunt trip, and now the elevators are out of service. All right. So this is just one of the versions of an apartment stretch. We use the FDNY hose pack. Just in the building we're in, this is going to be a shorter stretch. We know the fire apartment in this simulated situation is within about 25 feet of the stairwell. So we're not bringing every bit of hose up with us. It's just one of these stretches. Okay. So he's going to split that middle pack. So now he's got a 50-foot nozzle pack. He's got a 25-foot section of the middle pack, a 25-foot section of the middle pack, and then the 50-foot supply pack. Okay. You notice he slid the hose out from the bottom. He didn't pull the pack apart. So everything stays nice and neat. The nozzle man's going to carry the 50-foot nozzle section and the first 25 feet of that middle section with him. Because now that brought him 25 feet of travel related situation. We know it's a short stretch to the fire apartment. He lays the nozzle pack down at the apartment door, and then he's going to flake it out. He's then ready to call for water. The guy at the outlet, once he's connected, he could be dealing with the supply pack already here. We already would know it's excess, but we had him wait just so everything's done where it can be seen in the video. For us, we don't open another door and put it on the floor below. We keep everything within the confines of the stairwell. So he's just going to take that midpoint and take it down the stairs. I said we don't open doors, but that one's open just for light, for filming the video. He's just going to take it down the stairs, make a nice loop with it, and we're ready to go. Okay. So that's how we do an apartment stretch. Like I said, that's a short one. It's not taking much of the middle pack with us up there. And then you have a stairwell stretch. Now you're in a commercial building or you're in a residential building, but you don't have door control. You have fire or heavy smoke in the hallway, and you have to charge it in the stairs. So we flake the line up the stairwell. We take it to the floor above. What I learned teaching with Ray McCormack is we do what he does. We do 75 feet up. So it's the same concept as what we just did in that hallway of having 25 feet of travel hose plus the 50 feet for the apartment. Instead of having it all on the fire floor and it's all got to be in the stairwell, we've accounted for gravity helping with 25 feet of travel as well, not just the 50 feet for the fire apartment. Okay. So one of the things we do here by doing that is we might have to make the turn on the landing. Okay. So by doing that, we have to be very smart about where we put the nozzle. If the nozzle was on the opposite side in this picture, the inside of that return, and we went around the turn at the top on the landing, we would pull and have to fight friction the whole way. You'd have to staff that turn. You're not going to staff it when it's in the chimney. It's in the stairs. We open the fire door, or the fire floor door, and it was in the hallway. By putting the nozzle on that outside wall, you're able to pull the line down, and it's never going to fight that turn, right? Because that side that's on the wall, on the turn, is going to be charged. So it's basically going to operate like a runner and allow that hose to run down it. And then when you get to that last section that's around the turn, instead of fighting the turn, it's going to pull it into the stairs and allow it to go right down the stairs. Okay. We try to make sure the nozzle is positioned a few feet from the door because you got to be able to open the door, right? You put it right up against the door, you now have a couple 100-pound door stop. You got to push up the stairs, and then we're going to bleed the line. Okay. So nothing about the hookup is going to change, just the way we stretch it. All right, so same thing. He's got 50 feet and he split the middle bundle so he can divide it into 25 and 25. so that he can take 25 feet of travel hose with him. All right, so he's got 50 for the apartment, 25 of travel, and we're going to allow gravity to take care of both of these for us. So it's a little bit easier for us to move down the hallway. Okay, so he gets to the landing. He's just going to drop that 25. He's going to place the 50 feet of the nozzle section on the stairs and then look at the nozzle. Okay, so he flipped the pack to make sure that nozzle is oriented onto that outside wall of the return, not on the inside of the return. He's going to take the midpoint, step inside of the loop and get his arms nice and wide and just take it up the stairs. Okay, once he gets to the landing, he gets it nice and flaked out. Everything's tight. Well, now we want to get that 75 up. So we want the coupling to the top of the stairs. So he's going to pull up the female side, get the coupling to the top of the stairs, and then flake it out. And as long as you put that nozzle on that outside wall, you can make the turn. All right, so that's what I had for 2 hours on standpipes. If you want to contact me, if you have questions, here's all the ways to get in touch with me. If you want copies of the videos, I have some of them on Google Drive or Dropbox, one of the two, and I can send you copies of those videos. So just feel free to reach out if you have questions. If anyone has any questions right now, we can do a few. But if you do have questions later, you don't want to ask here, feel free to reach out to me. Or if you want copies of those videos, let me know.
All right. With that said, I will kind of keep an eye on the chat and questions and make sure nobody has a last minute question at the end. But thank you very much for coming on, Captain.
Oh, anytime.
Really appreciate you sharing all your knowledge and
anytime.
learned a lot on standpipes and also your city and everything else. So really cool information.
No, appreciate it.
Some Fire Nuggets things. Next week to continue on, we have Nick Peppard coming on to talk left seat tips and tactics, and that will be next Tuesday, I believe, the January 17th. So I see no other questions or comments, so we'll let everybody have a good night and catch you guys next time. Thanks again, Cap.
Right. Thanks again. Thanks for everyone's time.